Okay, so we know that the three-site equation for skin folds is just as accurate as the seven-site equation, so no reason to take as many as seven sites. What we want to do is we want to take the three different sites. Then we put them into these equations, such as the Jackson-Pollock standardized equation. Okay, this is going to give you body density, not body fat, and then you use an equation called either the Siri or the Brozek equation to just determine percent body fat, right? Now, these are standardized equations, which means that they work pretty well for your general population. There are more specific equations meant for specific groups, specific racial and ethnic groups, specific types of athletes, things like that. So to show you what these equations look like, I just want to show you what they look like. That these equations were developed by regression analysis. Basically, they said, okay, we know what the body density is because we've done hydrostatic weighing on these people. They're all based on hydrostatic weighing. Then they took all of the different skin folds and as well as any other information they knew about them, including their age, and they basically put them into computer software and they said, look, here's the calculation you can run through to figure out what the body density is. And again, I don't expect you to know these equations, I just want you to kind of have some idea of what they look like, right? So pretty much all you need is the gender, the age, and the sum of the skin fold. You've added up the three different sites, okay? And then you can figure out body fat from there. So what is typical body fat? Well, this is from the American College of Sports Medicine. They have a chart on body fat percentages for women. And note that above average means lower body fat, meaning above average leanness. So excellent for women under age 19 would be about 18%. Above average is 18 to 21, and average is 21 to 24. So usually in fairly lean female athletes are around 17 to 19 or 20%, and that's based a lot on my personal experience. I've done hundreds and hundreds and hundreds of body fat tests, right? 20-21% is still relatively healthy for women. It's not bad at all, right? We're starting to get 25 plus, not necessarily so healthy. We also have a chart for men, right? Men are going to be leaner, right? For excellent for men at age 19 or less is 11%. You can see how for women it's 18, right? So typically women are going to carry an extra 5, 6, 7% compared to the same men, right? First of all, women are going to carry more body fat in their breasts and in around their reproductive organs in their torso. Women also usually have less lean muscle mass than a man. So if you have two people that are 5'6", you can have a man and a woman that are 5'6". Even if they're both healthy and fit, the man is more likely to have more lean body mass, more muscle. So if he has more muscle, what that means is that means he's got more muscle compared to his fat as well. So simply the fact that men are more muscular, even if you have two people that are similar shape and size, a man and a woman, the man is usually going to have more muscle, the woman is usually going to have less. So that's obviously a generalization. That's the case most of the time. Okay, so here's a really important message I'd like to give you about measuring body composition. Body composition measurements are simple estimates. To be honest, none of them are very accurate. They give you a general idea of the level of fatness, but not an exact number. What these methods are really good for is measuring change. So if I do a hydrostatic weighing on you and you come out to be 15%, then I measure you next time and you come out to be 17%, you probably gained about that much fat. But we still don't know if you're exactly 15%, okay? The problem is there are lots of ways to introduce error. For starters, there's lots of error in the hydrostatic weighing. You can misestimate the amount of air in someone's lungs. They cannot get all the lungs out. You're making some assumptions about how dense their fat-free mass is. And then the skin folds and the biological impedance analysis, those are all based on hydrostatic weighing. So they can only be as accurate as hydrostatic weighing. Now, our standard deviation for hydrostatic weighing is approximately 3 or 4%. So what that means is if we measure 100 people that come out to be 15%, approximately 2/3 of them are going to be one standard deviation away. So if we measure 100 people that are measure at 15% body fat, right? 2/3 of them are going to be between 12 and 18%, so plus or minus 3. Okay. that means that also that 95 of them are going to be within 2 standard deviations. So that is between 9 and 21% body fat. But that also means that out of 100 people, 5 of the people we measure that come out to be 15% are actually going to be less than 9% or more than 21%. So for 1 out of 20 people, 5 out of 100, this body fatness test is almost completely meaningful. It could say that you're 15%, you're actually more than 21%, right? It's that case. So it's just an estimate. It's very good at tracking changes, but it's not really that good at giving actual numbers. Okay, so body composition and performance. So when we talk about body composition and performance, we want to maximize fat-free mass in some sports, right? If you're a strength athlete, you just want to maximize your fat-free mass. That's the most important thing. However, this can be undesirable for endurance sports, jumping sports, things like that. Anything where your body moves through face, you don't want to maximize fat-free mass. In those cases, what you want to do is minimize body fat, right? You want to minimize body fat if you're a triathlete, a cyclist, a runner, maybe even a gymnast, right? But if you're a shot putter, you're mostly concerned with maximizing the muscle mass. So that's something to keep in mind when we're setting goals for people. Okay, this gives a perfect example. We've got relative body fat in some elite athletes, right? We've got shot putters here, right? They're the most fat because they're not concerned really with how fat they are they? Shot putters are mostly concerned with muscle mass, right? When we look at our runners, they're all less fat. They're all farther down here on the body fat scale. Okay, we talked about before how it's not very accurate for some people, how 5% of the people are going to be either much fatter or much leaner than what the measurement gives us. Well, that may be the case with this 37% fat distance runner, right? You cannot be an elite distance runner and be 37% fat. It's just not possible, right? Elite distance runners do not have that much fat. Right? So this could be one of those people that is just outside the norm. They're more than 2 standard deviations away. Okay, so next video, we're going to talk about weight loss and severe weight loss and what is appropriate for weight loss.